Today we are going to discuss how to find the cube root of the given number using the prime factorization method. The prime factorization method is a simple method that we apply for finding HCF, LCM and square root, and that's the same process. That is this 1, 2, 1, 6, 7. We are going to simply find the factors. See, first step is try and find out using the rules of divisibility whether the given number is divisible by any number from 2 to 11 or not. And once we have done that, we are going to find if it is not divisible by any of the numbers within 11, then we are going to keep trying prime numbers after that. So see, it ends with 7, which means it's not an even number, so it's not divisible by 2. And see the last two digits, the number is not divisible by 4 as well, because we do not get this in the table of 4. So not 2, not 4 as well. It doesn't end with 5 or 0, so not 5 as well. We'll check the divisibility of 3 and 9 by adding some. We have to find the sum of the digits. So 1 plus 2 it's 3, plus 1 it is 4, plus 6 it is 10, and then we have got 7, that is 17. So 17 is not divisible by 3, so not divisible by 3 as well. Not divisible by 6 as well, since it is not divisible by 2 and 3, so definitely not divisible by 6 as well. 7, we can check for 7, 1 2 1 6 7, 1 2 1 6 7. It's usually better to divide and check. It's not, so not with 7 as well. Since it is not divisible by 2 or 4, so not divisible by 8 as well, so 8 is also not possible. Since we do not get the sum of the digit was 17, so it doesn't come in the table of 9, so not divisible by 9 as well. Doesn't ends with 0, so not comes in the table of 10 as well. 11, you have to check the digits, find the sum of the alternate digits, that is 2 and 6, that is 8, and 1 plus 1 2 plus 7, that is 9. So it's not divisible by 11 as well, because the difference in the alternate numbers should have been divisible by 11, so it's not. So not possible with 11 as well. And now once we have reached this position, we are going to try out all dividing the number with all the prime numbers after 11. So after this we have got 13 as a prime number, so let's check with 13. It will not be divisible. Then we can check the next number, 17. No, not possible. 19, not possible. 23, yes, it is possible. So 23, we get 529. Now we're going to apply a simple common sense. You are asked to find the cube root, which means 23 must be repeated at least 3 times. So definitely 529 must be divisible by 23. Then only its cube root is possible. So we will divide it by 23. Yes, we get 23. So again it terminates over here because we have reached a prime number. So we can write it this manner, that the cube root of 1 2 1 6 7 is 23. Now this simple trick should be applied by you at every point of time, so that we do not waste time dividing the number till 23. Now we'll move to the next number. See, we've got 35937. Again the same rule, 35937. It ends with 7, which is not an even number, so not possible to divide the number by 2 for sure. So we'll move to 3. Find the sum of the digits, that is 3 plus 5 is 8, plus 9 17, plus 3 20, plus 7 27. Yes, it is possible, because 27, 3 into 9 is 27. So it will definitely get divided by 3. So let's check. 35937 divided by 3, we get 11979. Again we are going to apply the common sense, that is, since we are finding cube, so the number must be divisible by 3 at least 3 times. So once we have already got, so two more times. So we will again divide it by 3. Let's find what the number would be. Divided by 3, we get 3993. 3993. This can be divided by 3 commonsensically. 3 ones are 3, 3 threes are 9, and again 3 ones are 3. Now if you are well versed with the table of 11 and the cube root list, then you would know that it is actually divisible by 11, because see, the 11 pattern will be 11. 11 square is 1 to 1. 11 cube is 1, 3, 3, 1. It will keep repeating itself in this manner. So 11 cube, we get 121, and again it will be 11. Now you see it will terminate over here because we have reached the prime number, that is 11. Now you see we've got a group of 3's and we have got a group of 11. So from each group we are going to take up one number at a time. So we are going to write it in this manner, that cube root of 35937 would be 3 into 11, one from each group. So from this 3 we have got 1, and from the next group of 11 we have got here 11. So 3 into 11 we get 33. So this will be the answer for this. Now we are going to move to some other question. 42875. Same rule. 42875. See, over here it doesn't end with an even number, so it's not divisible by 2. For checking divisibility of 3, let's find the sum of the digits. So 4 plus 2 is 6, plus 8, 14, plus 7, 21, plus 5, 26. Not possible with 3. Last two digits not divisible by 4 as well. Now 5. Definitely it is divisible by 5 because it has got 5 at the end. A number that ends with a 5 or a 0 is definitely divisible by 5. So this will get divisible by 5. Let's find the number. 42875 divided by 5, you get 8575. Again, we'll apply the common sense. We do not have to again try to divide the number by any other number. We know 5 will be repeated at least 3 times. So again divide the number by 5. So we get 1715. You see, it has to be repeated 3 times. So and you get a number that ends with 5. So definitely it will be divisible by 5. So by 5 we get 343. Now if you're well versed with the cube root list, you would know that this is actually the cube of 7. So divide 3 by 7, you see we get 49. See, we get 49, and 49, 7 square is 49, so it will get divisible by 7, and it terminates over here once we have reached the prime number. Now you see we have got a group of 3 5's and group of 3 7's, so we'll get one from each group. So we are going to write it, the concluding statement, that is the cube root of 42875 is equal to of 1 5 into 7, that is one from each group. So we get 5 into 7, 35. So this will be our answer.